In this video, we will solve an interesting question on profit maximization in case of monopoly. The question is, a monopolist has constant marginal cost of $1 per unit and zero fixed costs. It faces the demand curve, that is, demand is a function of price which is equal to 100 upon P, where P is less or equal to 25, or demand will be equal to 0 if price is greater than 25. So I have written here 0, so it is actually 25. What is the profit maximizing choice of output for the monopolist? We need to find out. So we have here, we have demand. If I write the demand function, so Q, quantity demanded, is equal to 100 upon P. Okay, we are being given that this monopolist faces a constant marginal cost of $1 per unit, and we have zero fixed cost. And what will be the profit maximizing choice of output for this monopolist? Okay, so here you can see, if I transpose this P here, so we have P into Q is equal to 100. So what is P into Q? It is actually the total revenue. That is, total revenue of the monopolist is 100. It does not change at all. It is constant here. Okay, what about the total cost of the firm? Monopolist, since marginal cost is equal to 1 and we have zero fixed cost, total cost will be equal to the integral of the marginal cost with respect to output. So total cost will be equal to 1 dq, and total cost will be equal to q here. Since we have zero fixed cost, so we don't add the constant of integration here. Simple thing, if marginal cost is constant, total cost will be equal to q in this case. Having said that, we know that profit of a monopolist will be equal to the total revenue minus the total cost. Now profit will be equal to, what is total revenue? Total revenue is constant, which is 100 here, minus the total cost is q. Since this is the profit function and we have the constant what we call total revenue here, so this profit will be maximum in this case, since we have only one variable here, which is quantity. So profit will be maximum when this quantity will be minimum. Okay, so when we have the minimum quantity, profit will be maximum for this monopolist. Okay, and since we know that Q is equal to 100 upon P, okay, we know this relation that is being given us the demand function. So since Q should be minimum to maximize profit, in this case this Q will be minimum when price will be maximum. Okay, there is inverse relationship here. So here Q will be minimum when price will be maximum. So what is the maximum price that this monopolist can charge? It's being given us here. P is less or equal to 25. So maximum price will be equal to 25. So quantity will be minimum when we have the highest price, in this case, which is 25, which will give us 4 is the quantity maximizing, rather profit maximizing quantity. So Q should be equal to 4. So here we cannot equate the marginal revenue with marginal cost like we used in our questions related to the profit maximization. If we do here, so total revenue is this, so marginal revenue, we equate marginal revenue with the marginal cost. So since total revenue is P into Q, which is equal to 100, in this case marginal revenue will be 0, and it is not equal to the marginal cost, which is 1. So we cannot use the marginal revenue is equal to marginal cost thing here. Okay, why this is interesting or somewhat different? It is actually the, if I write quantity on the horizontal axis, price on the vertical axis, we have actually a rectangular hyperbolic demand function. So for rectangular hyperbolic demand function, we have constant unit elasticity at each point. Okay, so elasticity of demand is constant. That means total revenue will be total revenue will be the constant in case of curvilinear demand function or rectangular hyperbolic demand function. Okay, so I hope I make myself clear in this video. Thank you.